Alright, today everybody, we are going to be applying the Pythagorean theorem that we did yesterday. We're going to be applying it to specific problems that only deal with right triangles. The very first thing I would like you to do in problem number 1 is identify what eventually you need to be able to find. And right now, what you need to be able to find is the length from x to y. So what I'm going to do right now is I'm going to color that in right here with this blue line so that I know that right there is what I'm attempting to search for. Okay? Now, right now, I know for a fact that I have a right triangle right here because there's a right angle, which means that this angle right here also has to be a right angle. So if you would, just label that 90 degrees and 90 degrees. Now, I'm going to color in 3 different sides. This first side will be in red. This side right here I will do in blue. And this side right here I'm going to do in green. Alright, we're going to go ahead and continue right here. I'm going to change one little thing. I'm going to change this color from blue just so that people aren't confused. I'll change it to this color. So right now, I want you guys to notice right here. This right here is a right triangle. Okay? And yesterday, we learned that if we take a side, we'll call this lowercase a, we'll call this lowercase b, and we'll call this lowercase c. If we have this side, and this side, we learned that if we take that side and make it into a square, and we add the length of the other leg made into a square, that's always going to equal our hypotenuse made into a square. So the area of A, when I say a square, what am I talking about? I'm talking about like this picture. Right? This is A made into a square, this is B made into the square, this is C made into a square. This squared plus this squared equals this squared. That's what I'm referring to. Okay. So what is our value for A? We don't know yet, do we? What is our value for B, though? 12. So we're going to put 12 squared. And what is our value for C, our hypotenuse? 15 squared. So you'll notice that when we square the 12, what do you get? 144. And that is equal to 15 squared, which is 225. And when you take away 144 from both sides, when you take it away from both sides, you get a squared is equal to 81. And when you take the square root of both sides, you get A is equal to a 9. So A equals 9. What did I say the most common Pythagorean triple was? What's the most common Pythagorean triple? 3, 4, 5. Look what happens when you multiply all those by 3. So automatically, without doing any math, all right, I'm doing this because I'm trying to teach you the process, but without doing really any complicated math, when I saw the 15 and I saw the 12, automatically I knew that was going to be a 9 because of the 9, 12, 15. Now, what are the other Pythagorean triples that every single high school student needs to know? You wrote them. Come on. 5, 12, 13. 8, 15, 17. 8, 15, 17. And last but not least, 7, 24, 25. Those are the most common. Are there others? Yes. You could type in Pythagorean triples in Google and you'll see a whole super long list of all the Pythagorean triples. These just happen to be the most common. Okay? And then you can multiply all the sides by 2, by 3, by 4, by 5, and get other Pythagorean triples. But these are their base. This is the most simplest form. So right now, why did I have to find this side first? Why did I have to find this side? Because I need to find this length right in here, which is 21. So I'm going to label this side 21. What does that mean? It means from right here to right there, that distance. I'll do a double arrow going across. Right here, from right there to there, that has to be what? 21, because 21 plus 9 gets me a 30. So you had to solve for this so that you could look at the other right triangle. So I'm going to shade in a totally different color. Check this one. Does everybody see the other right triangle right next to it? So now we're going to use the 12 and we're going to use the 21 to find our hypotenuse. So now you're going to do 12 squared plus 21 squared equals our hypotenuse squared. Bless you. So you get 144 plus, I think it's 441 equals c squared, which gets you a total of 585 equals c squared. And when you take the square root of both sides, c, I believe, is approximately equal to about a 24.2. By the way, I think the square root of 576 is 24. All right, so 24 squared is 576. So you can see how this is going to be a little bit bigger. Okay. Now, if I said I wanted the exact answer, you want the exact answer. Could I simplify the square root of 580? If I wanted to, that ends in a 5. What are all factors that end in a 5? What is it? What's the factor of that? All numbers that end in a 5, they have to have a factor of 5. They have to. That's one of the rules. So I know it's going to be a 5. So, what's 585? Divided by 5. 117. Now, there's another rule. If you add a 1 and a 1 and a 7 together, what do you get? A 9. Is 9 a multiple of 3? Anytime you take a number and you add all the numbers up, and if it's a multiple of 3, you know it's divisible by a 3. So I know that 3 goes into a 1, and a 7. 3 times 39. What's 3 plus 9? 12. Is 12 a multiple of 3? Yes. Therefore, I know I can divide it by a 3. 3 and 13. So here's what we have. Oh, didn't go that far over. Here's what we have. We have the square root of a 3 times a 3 times a 5 times a 13. Do you see any pairs? 3 and 3. That means I can pull out a 3 out of the radical. What still stays inside the radical? 5 times 13, which gets me a 65. Right? This is not the approximate answer. This is the exact answer. So watch this. I'm going to do it in the calculator because it'll probably make more sense. So you guys got 12 squared, right? Plus 21 squared. And what did that give us? That gave us 585. And then we took the what? The square root of 585, and we got the approximate value of 24.2. But then I said there was a more exact answer. We had to simplify the radical. And what did we say the final simplified answer was? Huh, interesting. What do you guys notice about these answers? They're the same. This is what's called something that has been simplified. Now, this is something that should have been taught to you in Algebra 1. So, for example, if you were given the square root of 8, could I simplify the square root of 8? Sure. I can break that down into a 4 and a 2, and a 4 can be broken down into a 2 and a 2. There's a pair. So the simplified version of the square root of 8 is 2 radical 2. You have to know how to simplify radicals. Okay? So if I say the square root of 20, can that be simplified? Why? Because it's broken down into a 4 and a 5, and 4 breaks down to a 2 and a 2. So what would this be? radical 5. What stays inside? What stays inside the radical? That's a 2 stays inside here, a 5 stays inside there. Okay? One more. Square root of 27. What does 27 break down to? 9 and 3. What does 9 break down to? 3 and 3. See any pairs? So what comes out? 3 radical 3. That's how you simplify radicals. You look for groups of numbers that can come out. You guys want one more? You guys good? Yeah, you bet. Square root of 5. Guess what? Can't do it. That is simplified. That's it. Square root of 13. Done. It's only 13 times 1. Yes, sir.
How did you get 2 radical 5 on 20? Because you took that one up there. Would you do that for all of them? Or?
You look for square roots. Look for groups of 2. Like for example, if I said the square root of 25, what is the square root of 25? Everybody knows that. 5. Why? Because it breaks down to a 5 and a 5.
So groups of numbers.
Groups. By the way, even though you can't see it, inside this index right here, there's a 2. Even though you can't see it, it's looking for groups of 2. Now, if you see something like a cubic root, if you see a cubic root, all right, you say, what's the cubic root of 27? Now it's not looking for groups of 2, it's looking for groups of 3. So if I have a 3 times a 3 times a 3, now I'm looking for groups of 3. So the cubic root of 27 would just be the answer of 3. Okay? So, on our problem, what I was trying to teach you to do was understand you can break down some radicals, and we broke down all the factors right here. So 3 times 3 times 5 times 13 equals 585. But you only had one group of, you only had a pair of 3s that you could pull out. So what did I do? I found the pair of 3s, pulled it out. What stays inside? 5 times 13, which is 65. Okay? So, your answer. Some of you are like, you're teenagers, so you're like, explain it. Your answer is approximately equal to 24.2, but the exact answer is 3 radical 65. Okay? So this is your exact answer. This is your approximate answer. That is the length of the distance of x to y. And you'll notice, what did we have to find first? We had to find the length of this side first before we could actually use that 12 in order to find our hypotenuse, which was the answer we were searching for. All right, one more problem and I'll let you guys go. Right now, it looks like we need to find the distance between Sesterich and Sanchez. Sesterich is right there, Sanchez is right there. We got to find the distance between those individuals. So what I want you to do is create a right triangle and find the distance between Sesterich and Sanchez. Good luck. Okay, so in order to find the distance between Sesterich and Sanchez, what I'm going to do is I'm going to make a right triangle.
Oh, I was
So I'm going to make a right
I was
triangle.
trying to use the Pythagorean theorem on, look, I don't know what I was doing.
So what you have to do is you need to train your brain. You need to train your brain to be able to create, especially on a coordinate grid. Look for a right triangle that you could build. Okay? So right now, does everybody see this right triangle right here? What's the distance of my smallest side? 3. What's the distance of my longest leg? 7. 1, 2, 3, 4, 5, 6, 7. Correct. So I'm going to do 3 squared plus 7 squared equals my, there's my c value, my hypotenuse squared. So I get 9 plus 49 equals c squared. Add them together, I get 58 equals c squared. Take the square root of both sides, and c is equal to the square root of 58. Now we'll try to simplify it, but I got good news. Sorry, I have good news. Because a 58 breaks down to a 2 and a 29. And what are the only factors of a 29? 1 and 29. So this actually is simplified. You can't simplify it more than the square root of 58. So right here, I'm just going to say the square root of 58. Press enter, and that's 7.6. So right here, if I wanted to find the approximate answer, I would say it's approximately equal to 7.6. But look what it says. It says tens of miles. Tens of miles. So what does every single tiny unit represent? Nope. A 10. So that's right there. That's 10 miles. So wow, how far away are they? Approximately 7.6 times 10. So you got about what? 76, about 76 miles. If you wanted to be a little bit more accurate, you could say 76.2 miles. And that's your answer. Now, before you guys move on to the next problem, we're going to give you some formulas here. Okay, some formulas that can maybe help you. All right. So everybody knows that c squared equals a squared plus b, right? Everybody knows. Okay. So c will always equal the square root of whatever a squared plus b squared is. So there's the shortcut for finding c. You find the square root of whatever a squared plus b squared is. You can put that in your journal, save it for later whenever you're needing to solve. Now, the other one is this. A squared will always equal c squared minus b squared, just like b squared will always equal c squared minus a squared. So if you ever want to just have a shortcut for a, it's always going to equal the square root of c squared minus b squared. And b will always be the square root of c squared minus a squared. So now you have every single possible formula you need for a c, for an a, and a b. And just remember, a and b are interchangeable. They're just the legs. What's the most important side you have to identify? Because that is always the hypothesis. If you don't know that, then you're not going to be able to really solve these accurately. So there's all of your formulas right there that you're going to need. The rest of this is going to be super, super easy to do.